Hello viewers, I'm Kausalya. Today we are going to solve problems 15 and 16 in exercise 12.3. The problem is, in figure ABC is a quadrant of a circle of radius 14 centimeter. So here you see A, B and this C is a quadrant of a circle and the radius is 14 centimeter. And a semicircle is drawn with BC as diameter. So here by keeping this BC as diameter, a semicircle is drawn like this. Find the area of the shaded region. So here again we need to calculate the area of this shaded part. Right. So here since we know only the value of this sides, okay, here it is 14 and again this will be 14. We don't know the value of BC, right? And again you see from the observation it is a right angled triangle, right? Because one angle is 90 degree perfectly. So here by using the Pythagoras theorem we are going to calculate the value of BC, because with the BC as diameter a semicircle is drawn, right? So we need to find the area of the semicircle. So it is mandatory to know the radius. So as a first step, we start with finding the value of BC, right? So in triangle ABC, even you can write by Pythagoras theorem. So BC square is equal to AB square plus AC square. So here AB and AC both the values are 14. So just substitute. So since we need to take the square, right? Because here it is BC square, I want only BC. So this 14 square plus 14 square can be written as 2 times of 14 square. Can you get? Because they are the same numbers, right? You see, I'll show this as an example. That is, just consider 2 plus 2. So this 2 plus 2 is 4. We can write it as 2 into 2, right? Again, that gives the same value. So the same thing followed here, okay? Because addition and multiplication, they are related to each other, right? Successive addition is multiplication. So the same way, 14 square plus 14 square, here I am writing it as 2 times of 14 square. So when you take the square root, what happens? So this becomes square root of 2. That is, I am going to take the square root of this entire term, 2 14 square. So square root of 2 becomes square root of 2 and this 14 square becomes 14, right? So here the answer is 14 root 2 centimeter. So this is the diameter of the semicircle. But what we need actually, we need radius. So just divide the value of diameter by 2. So 14 by 2 becomes 7. So 7 root 2 centimeter. So as we know the radius, we can easily find the area of the semicircle. So area of the semicircle is pi r square by 2. So here pi is 22 by 7. The value of r is 7 root 2. So just substitute it, whole divided by 2. Now I am going to move this 2, right? Just I am rewriting the expression, that's it. So write the numerator part as such and this 2 I am writing it as 1 by 2 here, right? So 7 and 7 they remain as such, root 2 into root 2 becomes 2. So this 2 and 2 get cancelled and this 7 and 7 cancel, and finally here I am ending up with the answer as 154 centimeter square, because it is area, so here it is square, right? So now as a next step, you see here, now we have calculated the area of this semicircle, right? The next step is, now we are going to find the area of this sector, right? So as we know that here the angle is 90 degree. So and the value of r is 14, it is directly given. So just substitute it over here. So theta by 360 into pi r square. So the value of theta is 90 and pi is 22 by 7 and the value of r is 14. So here again, here the answer is 154 centimeter square, right? Okay, don't get panic if you have the same values again, right? Everything is fine. So now here we are calculating the area of the triangle ABC. So here the formula is half into base into height. So again when you look at the problem, so here this is your base and this is your height. All are having the same value, 14 centimeter, right? So when you multiply off into 14, that gives 98 centimeter square. Right. So now we have to look at the problem carefully. You see, now we have calculated the area of the triangle, right? And I know the area of the sector, right? So what I actually need? I need the area of the shaded region, right? So as a first step, I am calculating the value of this part, right? So that I can subtract this value from this entire area of the semicircle, right? Can you get? Because we need only this part. So in this semicircle, this is the extra thing which is to be removed, right? So the only way to find the area of this part is you have to find the area of this sector and you have to find the area of this triangle. So you have to subtract the area of this triangle from this sector, right? So area of the sector is 154 and area of the triangle is 98. So when you subtract here, the answer is 56 centimeters square, right? So once we have calculated the area of BQC, that is, now we know this part, right? Now we know this value BQC. So once you subtract this value from the area of the semicircle, then you can find the area of the shaded region, right? So area of semicircle minus area of BQC. So here the area of semicircle, it is 154, right? And area of BQC, it is 56. So 154 minus 56 gives 98 centimeters square, right? So this problem gets over here. We will proceed with our last problem of this exercise. So problem number 16. You see, calculate the area of the designed region in figure common between two quadrants of circles of radius 8 centimeter. So here, this is your shaded region, right? So we need to find the area of this shaded portion. So here the radius is given as 8 centimeter, right? And here we are having two quadrants of circles, right? So what are all those two quadrants? You see, this is one quadrant, right? That is ADC with this red part, okay? They form one quadrant, and this ABC with this red line forms other quadrant, right? So these two quadrants are somewhat mingled, right? And here we have to find this area. This is the area of the designed region, right? So as a first step, you see here, anyway, this is a sector, right? Sector as well as quadrant, okay? Both means the same. So first we am calculating the area of this sector, right? So I am calculating this part, BAEC, right? And obviously here the angle is 90 degree. This is given in the problem too. So theta is 90 and the value of R is 8. So just substitute and find the value, right? And 90, 360, they cancel by 4 times, and again this 4 and 8 get cancelled. So finally here I am ending up with the answer as 352 by 7 centimeters square, right? So this is the area of the sector. So you see, I am calculated the area of the sector, okay? I have calculated the area of the sector. But how to find the area of the shaded region? To find the area of the shaded region, you see here, I am drawing a line like this, right? A straight line. Right. So this is a line. So here, you see, I have calculated this area of the sector. And when I subtract the area of the triangle from the area of the sector, what will happen? So obviously we can find the area of 1/2 of the shaded region, right? You see, let me explain. You see, this is the area of the quadrant or area of the sector, right? And this is the area of the triangle. So once I calculated the area of the sector and when I subtract the area of the triangle, then obviously I will be getting this value, right? Right? The same thing now we are going to do. So just consider the triangle A, B and C. Right. So here again this is of the value 8 and this is also having the same value 8. So when you substitute, so 1 by 2 into 8 and this 2 and 8 they get cancelled. So finally the answer is 32 centimeter square. Right. So now as I just explained, we are going to find the area of this segment. Let us again look back at the problem. So you see now I know the value of this sector, I know the value of this triangle. So when I subtract the area of triangle from the area of the sector, I can easily find the value of AEC, this part, right? So area of the sector minus area of the triangle, right? Just substitute the values, and once you take LCM and simplify, finally I am getting the answer as 128 by 7 centimeter square. And you see this is the area of half of the shaded portion, right? You see, okay, when you look at this diagram it will be more clear. I'll start with this, right? Then I'll go here. You see here, this is the part and I have subtracted this one. So I had calculated area of this portion, right? Only half of the shaded portion I had calculated. So since they are similar, right, just you can multiply the value of this shaded portion by 2 so that you can get the entire value, entire area of the shaded region. Right, because they all have the same value of radius as well as the angle, everything. Therefore, area of the shaded region here is area of AEC multiplied by 2. So 128 by 7 into 2 gives the final answer as 256 by 7 centimeter square. So here comes the end of this exercise as well as this problem. If you have any doubt, let me know in the comment section. Thank you.